Hello everyone, and welcome to this session. Today we'll be discussing an essential service in cloud infrastructure, Elastic Load Balancer, ELB, in AWS. What is load balancing? Load balancing is the process of distributing incoming network traffic across multiple servers or instances to ensure no single resource becomes overwhelmed. When we have thousands, or even millions, of users accessing our application, traffic naturally increases and varies throughout the year due to different operational and business factors. The Elastic Load Balancer decides which EC2 instance should handle each request, based on availability and performance. In essence, ELB ensures that traffic is evenly and intelligently distributed, avoiding overloads and enhancing performance and reliability. Why use load balancing with EC2? AWS ELB offers many benefits when working with EC2 instances. Distributes workload across multiple EC2 instances, balancing performance. Handles instance failures gracefully by detecting unhealthy instances and rerouting traffic to healthy ones. Performs automatic health checks to monitor the status of each instance. Increases security by integrating SSL/TLS certificates through AWS Certificate Manager, ACM. Supports multi-AZ deployment, enabling high availability across different availability zones. And the best part? AWS manages the ELB infrastructure for you, including availability, updates, patches, and scalability, so you only focus on configuration and integration. Health checks in ELB. Elastic Load Balancer continuously performs health checks by sending requests to a specific endpoint, e.g., /health, on each EC2 instance using a defined protocol and port, like HTTP on port 4567. If an instance responds with a status code other than 200, ELB considers it unhealthy and temporarily removes it from the load balancing pool, ensuring uninterrupted service for end users. Integration with AWS services. ELB integrates seamlessly with other AWS services such as Amazon EC2, Auto-Scaling Groups, Amazon ECS, AWS Certificate Manager, ACM, Amazon CloudWatch for monitoring. This makes it a powerful component in any cloud-based architecture. Types of Elastic Load Balancers. AWS currently offers 4 types of managed load balancers. Load Balancer Name Released Use Case. CLB Classic Load Balancer 2009 Legacy Use, soon to be deprecated. ALB Application Load Balancer 2016 Layer 7, HTTP/HTTPS, Traffic Routing. NLB Network Load Balancer 2017 High Performance TCP/UDP Traffic. GWLB Gateway Load Balancer 2020 integrates third-party appliances, firewalls. Note: it is highly recommended to use the newer generations, ALB, NLB, GWLB, as AWS continues to enhance them and phase out CLB. Sticky Sessions, Session Persistence. ELB supports sticky sessions, which bind a user session to a specific EC2 instance. This means all traffic from that user will always go to the same instance. Use this feature cautiously, it may defeat the purpose of load balancing by creating uneven traffic distribution and potential bottlenecks. Cross-zone load balancing. Cross-zone load balancing. This feature allows the load balancer to distribute traffic evenly across all registered instances in all availability zones, AZs. In the diagram, we can observe a user, and this user is connected to 2 load balancers. The traffic generated by the user will be sent to both load balancers. One load balancer has a load of 40, and the other has a load of 30. These load balancers are responsible for distributing that traffic among the instances registered under their domain. We can see that each load balancer will be responsible for handling 10% of the total traffic generated. Since all instances respond to a load balancer, in this diagram we can observe that Zone 1 communicates with Zone 2. In this way, If no available instances are found in Zone 1 to receive the traffic, the cross-zone balancer will query Zone 2 to check for availability. Upon finding available EC2 instances, the traffic will be routed accordingly, assigning 10% of the load. Likewise, the load balancer in Region 2 will assign 10% of the traffic to all of its registered instances. In this example, the numbers are hypothetical. Without cross-zone load balancing. Here, requests are distributed only among the instances that belong to the node of the specific elastic load balancer. Unlike the previous example, the load balancer here has a load of 50, which is distributed equally. In this diagram, all traffic is assigned only to the instances under the domain of each load balancer, and the zones do not communicate with each other, as shown in the current diagram. The operation carried out by the load balancer is to distribute the traffic load only among the instances within its own domain. Summary. Elastic Load Balancer in AWS is a fully managed, scalable, and intelligent traffic distribution service that improves the performance, reliability, and security of your applications. It's tightly integrated with key AWS services, easy to configure, and essential for building highly available cloud architectures. Thank you for your attention. I look forward to seeing you in the next session.